everyone, welcome back to my channel. In this video, I'm going to talk about the elementary row operations. If this is your first time here, and if you want to upgrade your math skill and boost your grade, make sure you subscribe my channel by hitting the subscribe button below so that you won't miss any videos in future. If you find that this video is useful, please share to your friends, to your students, or to anybody who needs this. So, let's start the lesson right now. Today, I'm going to talk about the elementary row operations. There are three types of elementary row operations. The first one is we can interchange any two rows, and the notation can be written as this. The arrow means replace. So for example, I can replace row 1 with row 3 and row 3 with row 1. Then the second type of the operation is I can multiply any row I with a constant k, then replace the result to row I. So the notation can be written as this one. Then this type of operation is suitable to use if we want to change any element to 1. Then the third type of operation is we can multiply any row j with a constant k, then we add the result to another row I, and the result replace the row I. So the notation can be written as this. And this type of operation is suitable to be used when we want to change any element to 0. These elementary row operations can be used to find the inverse of a 3 by 3 matrix. To do this, first we need to write the matrix together with identity matrix side by side, and in between it is separated by using a straight line. So this kind of matrix, we call it as augmented form of the matrix. Then after that, we are going to carry out all kinds of suitable elementary row operations until the matrix on the left hand side becomes an identity matrix. Once this has been done, then we can make conclusion that the inverse matrix is this one. Since there are so many numbers or so many elements here need to be changed, then students may get confused which number must be done first, followed by which number. So here I have a suggestion here. You can follow this sequence where first step you can change this number into 1, then followed by step 2 you change this number into 0, then step 3 change this number into 0. After this has been done, step 4 you change this number into 1. Then step 5 you can either change this into 0 or change this into 0. So after step 5, then you go to step 6, or after step 5 go to step 6. After finish, then we continue to step 7 and we change this one into 1. Then finally we can change these two numbers into 0. Either we can change this one step number 8, then this one step number 9, or you can change this one step number 8, this one number 9, it is okay. Now let's look at this example. It is given that A is a 3 by 3 matrix given here, and find the inverse matrix A by using elementary row operations. Now to do this, first I need to change this matrix into augmented form, where I combine this matrix with an identity matrix in between using a straight line to separate them. Then next I need to decide which elementary row operations is suitable. So here, first I'm going to change this into 1. So to change this number into 1, now I have two methods. One is I can multiply this number with negative 1 over 3. Or another method is I can interchange row 1 with row 2 in order to get this number 1. So when I compare, I found that interchange row 1 with row 2 is easier. So now I decide to use this operation where I interchange row 1 with row 2 and row 2 with row 1. So after interchange, now I get this one. The whole row 2 replaced with row 1 and row 1 replaced with row 2. Now step 2, I'm going to change this number into 0, and step 3, I'm going to change this number to 0. So means all the elements in row 2 and row 3 will change, but the row 1 remain unchanged. First, I'm going to determine the suitable operation for this. Now first, in order to change negative 3 to 0, I need a positive 3. So I can get the positive 3 from row 1, where I'm going to multiply row 1 with positive 3. Now add into row 2. So means I'm going to use this operation where I'm going to multiply 3 to row 1 and add into row 2. Once I have determined the suitable operation, so now all the elements in row 2 will be changed by using this operation. So means for the first number, negative 3, so 3 multiply 1 is 3, add to negative 3, so 3 minus 3 is 0. Then this one, negative 3 multiply 3 is negative 9 plus 3, then we get negative 6. Then for this number, 2 multiply 3, it is 6. 6 plus negative 1, it is positive 5. Same thing for the matrix on the right hand side. The 0 multiplied with 3 is 0. 0 plus 1 is 1. Then 1 multiply 3 is 3 plus 0, it is 3. Then 0 multiply 3, it is 0 plus 0, it is equal to 0. Now step number 3, I'm going to change this number into 0. So to change this number equal to 0, I need a negative 2. So means I'm going to use the row 1. So row 1 I can multiply with negative 2. So the answer we add into row 3 in order to get this one equals to 0. So means I'm going to use the operation. Once I have determined the suitable operation, now all the elements in the row 3 will be changed by using this operation. So now let's look at the first number 1 will multiply negative 2. Negative 2 plus 2 is equal to 0. Then negative 3 multiplied with negative 2 is positive 6. Positive 6 plus negative 1, we will get 5. Then 2 multiplied with negative 2 is negative 4. Plus 0, it is negative 4. Then on the right hand side, 0 times negative 2 is 0. Plus 0, it is 0. 1 times negative 2 is negative 2 plus 0, it is negative 2. And 0 times negative 2 is 0 plus 1, it is 1. Now after finish step 3, now I go to step 4. That is, I'm going to change this value into 1. So means the values in row number 2 will be changed, but all the elements in row 1 and row 3 remain unchanged. First, I need to determine the suitable operation. So since my target element is changing negative 6 to 1, so I can use the first operation where I multiply row 2 with negative 1 over 6 in order to change this value into 1. That is, I'm going to use the operation where I multiply row 2 with negative 1 over 6, and the result will replace the new row 2. So now we start from the first number. The 0 times negative 1 over 6 is equal to 0. Then second number, negative 6 times negative 1 over 6, it is 1. The third number, 5 times negative 1 over 6, it is negative 5 over 6. And same as the right hand side, 1 times negative 1 over 6 is negative 1 over 6. 3 times negative 1 over 6 is negative 1 over 2. And 0 times negative 1 over 6 is equal to 0. Now once I have finished step 4, now I'm going to continue to step 5 and 6. So for step 5 and 6 means I'm going to change this negative 3 into 0 and also change this 5 into 0. So means all the elements in row 1 and row 3 will change, but all the elements in row 2 will remain unchanged. Here you can either change negative 3 to 0 first, followed by 5, or you can change 5 into 0 first, followed by negative. So here I decide to change negative 3 to 0 first. First, I need to determine the suitable operation. So now in order to change this target element negative 3 to 0, I need a positive 3. So this positive 3, I can get it from row 2. Means I can multiply row 2 with positive 3 and add into row 1. So this one becomes 0. So now I'm going to use the operation 3 times row 2 and add into row 1. So the result will replace the row 1. So now each of the element in row 1 will follow this operation. Now we start from the first number. Now the first number in row 2 is 0. 0 times 3 is 0. Then 0 add 1, it is equal to 1. Then for the second number in row 2 is 1. 1 times 3, it is 3. So 3 add into negative 3. So we get 0. Now third number in row 2 is negative 5 over 6. When negative 5 over 6 times 3, it is negative 5 over 2. So negative 5 over 2 add in 2, then we will get negative 1 over 2. Now we come to the fourth number in row 2. Fourth number in row 2 is negative 1 over 6 times 3. It is negative 1 over 2. Add to 0. So we get negative 1 over 2. Then number 5, number that is negative 1 over 2 in row 2 times 3. It is negative 3 over 2. Negative 3 over 2 plus 1. It is equal to negative 1 over 2. Now the last number in row 2 is 0. 0 times 3, it is 0. 0 plus 0. So now the last number is equal to 0. Now we go to row 3. In order to change 5 into 0, we need a negative 5. So we can get the negative 5 from row 2, where row 2 times negative 5 add into row 3 in order to get the target element into 0. So now here the suitable operation is negative 5 times row 2 and add into row 3. Now we look at the first number. So the first number in row 2 is 0. So 0 times negative 5 is 0. Then 0 and add into the first number in row 3 is 0. So we get 0. Then for the second number, in row 2, second number is 1 times negative 5. It is negative 5, add into row 3, so negative 5 plus 5, then we get 0. Then the third number in row 2 is negative 5 over 6. So negative 5 over 6 times negative 5, it is positive 25 over 6. And add into row 3, that is negative 4. Then we get 1 over 6. Then followed by the fourth value in row 2. Fourth value is negative 1 over 6 times negative 5. It is equal to positive 5 over 6. And add into row 3 0. Then we get 5 over 6. Then up to number 5 in row 2, it is negative 1 over 2 times negative 5. It is positive 5 over 2. Positive 5 over 2, add into negative 2, then we get 1 over 2. So the last number in row 2, it is 0. 0 times negative 5, it is 0. Add 1, so it is equal to 1. Now after finish step 6, we need to go to step number 7. Now step number 7, we need to change this element into 1. When change this element into 1, we can multiply the row 3 with positive 6. And the row 1 and row 2 remain unchanged. So means the suitable operation for this is we multiply all the elements in row 3 with positive 6. So when we multiply all the elements in row 3 with positive 6, then we get this one. After the step 7, now we go to step 8 and step 9. So we can either change negative 1 over 2 to 0 first, followed by negative 5 over 6, or we can change negative 5 over 6 into 0 first, followed by negative 1 over 2. So the row for row 3, it is unchanged. Now we go to row 1 first. In order to change negative 1 over 2 into 0, we need a positive 1 over 2. So positive 1 over 2, we can get it from row 3. That is I multiply row 3 with positive 1 over 2, then add into row 1. So now the suitable operation is 1 over 2 times row 3 and add into row 1. Now we go to the first number. The first number in row 3 is 0. So 0 times 1 over 2 is 0. Then 0 plus 1, then it is equal to 1. Now for the second number in row 3 is 0. 0 times 1 over 2 is 0. 0 plus 0. Now it is equal to 0. Now the third number in row 3 is 1. Then 1 times 1 over 2 is 1 over 2 and add into negative 1 over 2. Then it is equal to 0. Now the fourth number in row 3 is 5. 5 times 1 over 2 is 5 over 2. Then 5 over 2, add in negative 1 over 2. Now it is equal to 2. Then the fifth number in row 3 is 3. 3 times 1 over 2 is 3 over 2 and add into negative 1 over 2. It is equal to 1. Then the sixth number is in row 3 is 6. Then 6 times 1 over 2 is 3. 3 times 3 plus 0, it is equal to 3. Now we go to row 2. Row 2, in order to change negative 5 over 6 into 0, we need a positive 5 over 6. So we can get the positive 5 over 6 by multiplying row 3 with 5 over 6 and add into row 2. So the operation is going to be 5 over 6 times row 3, add into row 2. Now we go to the first number in row 3. First number in row 3 is 0. 0 times 5 over 6 is 0. 0 plus the first number in row 2 is 0. So 0 plus 0, it is equal to 0. Then in row 3, the second number is 0. 0 times 5 over 6 is 0. 0 plus 1, it is equal to 1. Then the third number in row 3 is 1. 1 times 5 over 6 is positive 5 over 6 minus 5 over 6, it is equal to 0. Then up to number 4, the fourth number in row 3 is 5. 5 times 5 over 6, it is 25 over 6 and add into negative 1 over 6. Now it is equal to 4. Then the fifth number in row 3 is 3. 3 times 5 over 6, it is 5 over 2. Then 5 over 2, add in negative 1 over 2, it is equal to 2. Then the last number in row 3 is 6. 6 times 5 over 6, it is 5. So 5 add into 0, then that is equal to 5. When we come to here, we can notice that the matrix on the left hand side, it is the identity matrix. So in this case, we can make conclusion that the inverse matrix is the matrix on the right hand side. So therefore, the inverse matrix A is this one. So that's all for now. Do you understand what you learned today? Let me know in the comments below. If you find that this video is useful, hit the like button. Don't forget to subscribe to my channel. Thank you so much for watching. I hope you keep on learning and keep on watching my videos. And I hope to see you soon. Bye!